Today we're going to be learning about exothermic and endothermic reactions. Now this might sound like a bit of a mouthful, but essentially it's only talking about reactions that get hot and cold, and most chemical reactions are like this. Anyone who's ever mucked around with their fireplace and got burnt with the hot wood and the flames knows what an exothermic reaction is, because as wood burns it releases heat and light energy. And anyone who's been hurt on a sports field and they've had one of those instant ice packs, well, that's an example of an endothermic reaction. Now every reaction has two parts, and we need to understand this in order to understand how these reactions work. First of all, the substance that's going to be used to make the new substance has to break apart first. And then you have to take the atoms from that substance and join them back together in a different formation to make something new. So here we have an example. Here are three molecules. The two first small ones are held together by what we call single bonds, and the third molecule there is held together by what we call double bonds. So we have 6 atoms joined by bonds together. Now those bonds are actually energy. So the little yellow marks there are actually me showing you energy that's holding those atoms together. Now if I split those atoms apart, I remove the energy that holds them together. And that energy had to go somewhere. Essentially, it's sent out into the environment when we split the atoms apart. It's released. But then those atoms can't just float around anywhere. They actually have to be then put back together again. So next, we put these back together in a different formation to make something new. In this case, the two little atoms have reformed with one of the bigger atoms to make 2 new sets of molecules. But there's an issue. We've got to figure out where the energy has come for those bonds. Now if you have a look here, the energy that's in the bonds there is actually smaller than the energy that we had in the first lot of substances over here. So that energy is less than what we had to begin with. So where did the rest of this energy go? Well, essentially anything left over that wasn't used up is released as heat or light or electricity or sound. So if the energy that you need to make something new is less than what you released when you chopped up the atoms, you actually end up having a surplus of energy which is released. Hence the whole thing heats up and lights up and you hear a sound, and sometimes electricity is released as well. So that is called an exothermic reaction, a reaction that releases energy, because the bonds of the new substance don't need as much energy as the bonds of the original substance that it was made from. Now this is a reaction from real life. The first 2 atoms there, or molecules, were hydrogen gas, and the second was oxygen gas. Put them together and rearrange them and you end up with H2O, or water. So this is actually an example of an exothermic reaction where 2 gases, hydrogen and oxygen, go together and you actually form water from them. And anyone knows if you've lit up these gases, not only do you form water droplets, but you have a huge explosion of sound and light and heat. Now the opposite can also happen. Sometimes reactions get really cold because the atoms have to steal energy from the environment to put themselves back together again, and this is called endothermic reactions. So here I've got an example. Nitrogen gas. We have this in the air all the time. We also have oxygen gas in the air. Now notice how much energy is holding the nitrogen gas and the oxygen gas together. Their atoms don't need a lot of energy. Then if we take them and split them up, that energy is released into the environment, and we've got little nitrogen atoms and oxygen atoms floating around. Now they don't stay like that. They've got to be put back together again. This is what happens. They rearrange into a nitrogen joining up with an oxygen each. But look at how much energy is needed to hold those bonds together, a lot more than what it had to begin with. So where did the extra energy come from to hold these atoms in place? Well, they actually had to steal it. They had to take it from the environment in order to join the nitrogen and the oxygen atoms together. Because of this, everything around the area will actually start to get cold, because anything that the nitrogen and the oxygen atoms are touching will actually suck the energy out of them. So if this is happening in a balloon, or if this is happening in a little beaker, you'll actually feel the glass getting cold because the atoms are actually having their energy sucked from them. They're slowing down their vibrations because their energy is being pulled into this reaction to join the nitrogen and the oxygen together. So everything gets cold around them. Of course, this is what we call an endothermic reaction. So you're going to be taking these notes down that are on this page. Essentially, to revisit, endothermic reactions steal heat from the environment to reform their bonds. That means everything gets cold. That's because the breaking of the bonds releases some energy, but they need more energy to make the new bonds. And exothermic reactions release heat to the environment, or energy, because sometimes it's not just heat, it can be sound, light, electricity. And when reforming the bonds, we actually feel heat or hot. And that's because when you break the atoms apart, you release energy, but you don't use all of that energy up to make the new bonds. And there you have it, endothermic and exothermic reactions.